This video covers an overview of functions and looks at the type of functions in the IB Maths AI course. So this is in topic 2 functions. In topic 2, it's kind of split in two halves for the AI course. We have linear equations and graphs, and then we have functions and their applications, so applications of functions. And we're talking about that part of it now. What a function is, looking at the type of functions, how a function works, etc., etc. So in this video, I'm going to explain what my interpretation of a function is, go through a simple example, and then go through the different types in the AI course. So let's get started. The way that I describe a function to students is it is a description by a mathematical rule, so f of x equals something. So it's a description of the relationship between two variables. Now, one of the variable is the input or independent variable. I often interchange between these two words. They mean the same thing. So which one is the independent variable? And we call that x. And then the output or dependent variable. Now, with function notation, we call that f of x. Back with equations, that would be the y variable. So a question that I like to pose to students when they're thinking through a function question is, how is the output variable influenced by the input variable? And that'll be the relationship between the two variables. Now let's go through a very simple example here, and this one will be a linear function, but I'm more interested to try to think through what a function is and the two different types of variables. So let's talk about the height of a growing child. Now I looked up before this video the rough height of a child when born, and that's about 50 centimeters. Now I'm going to, just so I have nice whole round numbers, I'm going to assume that they are a very fast growing child and they get to a very high height by 15 years old, and let's say they get to 200 centimeters, which is the height of a basketballer by the time they're 15 years old. And you'll understand why in a second, why I chose those numbers, so they're nice and round. But before we get into that, let's just talk about our axes here. Which one is the independent variable and which one is the dependent variable or input output? Now for the height of a child, their height is dependent on their age. So the dependent variable is height. It depends on the input, which is their age. So I'm going to put input of age on the x-axis. We put the independent variable on the x-axis. Let's call that A, and the height depends on the age. So we'll call this height. Now I'm going to use function notation here, and the proper function notation looks like this. Now usually we have, you'll have seen sort of f of x, but it doesn't have to be an f. We use f because f sort of is the first letter of functions. It doesn't have to be an f. In here, I interpret this as h of a, or the height for a given age, h of a. Now I want to plot the height over the first 15 years of this kid's life. So let's just say here is 0. I'll just do increments of 5, 10, 15. And I mentioned before that let's assume that their height at birth, so 0 years old, is 50 centimeters. So let's call this 50. And let's say they get to a total height of 200 centimeters at the age of 15. So that'll look something like this. Let's say this is 200. And let's say it's a linear function. Now, it may not be because teenagers go through growth spurts, but let's just assume that it is a linear function. So we have this, and it goes up like that. So at any point in time, I can estimate the height of this kid depending on their age. So for example, at 10 years old, I would simply just need to go up, find where that line is, and then go across. So this here is a visual representation of the function. Let's now put some values into it and sort of set up a function. Well, the height of the kid for a given age, so h of a, will equal, now this will kind of test your understanding of linear equations, so mx plus c, but I won't go into too much detail on that because I could spend a few minutes on that, but it will equal the initial height, 50, as my constant, plus it's going to be 10 centimeters per year. And the way that I did that is this child increases by 150 centimeters over a period of 15 years. So it's 10 centimeters per year. Now, if I rearrange this in the form of y equals mx plus c, a linear line, it'll be 10a plus 50. So this right here is an example of a function. It describes the relationship between the age of this kid and this kid's height. So the height for a given age is equal to, and I can estimate the height for the input variable A. So if I wanted to find the height after, say, 10 years, I would input in A equals 10. 10 times 10 is 100, plus the 50 would equal 150 centimeters as an estimate. So there's a very basic example there of a function for a real-life scenario, which is the height of this child. Okay, let's now just briefly go through the different types of functions that you'll encounter in the IA course. The AI course. I was thinking about the IA for a second there. So we have in the SL and HL course, there are 5 different, so it's a linear functions, which we just gave an example of there. Quadratic functions, that might be, say, the height of a ball when thrown into the air. That's a very common example of a quadratic function. Exponential functions, the common example of that is population growth of either humans or some sort of animal. Logarithmic, also, that could be, say, the growth of bacteria, which might flatten out over time. Sinusoidal functions, the most common example of that is the tides, say the tides in a river or the tides of an ocean. It goes up and down over a period of roughly sort of 12 hours. And then in the HL course, there are 2 more, logistic functions, which is kind of a combination of exponential and logarithmic. So examples of logistic functions is also probably population growth of something. And then also piecewise functions, which is a series of functions sort of pieced together. And an example why that's important, if I go back to my simple height example, once this kid hit the age of 15, he wouldn't keep growing at the same rate. Otherwise, at some point, he's going to be 300 centimeters, and that's unrealistic. So at some point of time, if he hit his maximum at 15, he would actually flatten out and stay 200 centimeters. So this would be a piecewise function. So it would be a linear function, 10a plus 50 up to 15, and then it would stop, and then a different function would start after 15, and that's what a piecewise function is. Okay, so this video covered what a function is, the function notation, how to think about it in terms of inputs and outputs and the relationship between the two, and then just went through the types of functions that you will encounter in the AI course.